Welcome back to our next lesson. This one is on adding and subtracting fractions. So pause it real quick, get your title, your learning target, go ahead and fill in the date, and then draw your big line and your line down, and then we'll be ready to go. So today's lesson is on adding and subtracting fractions, but they're going to involve some integers, some positives and negatives. So real quick, just to kind of jog your memory and kind of get you thinking about integers again, let's jot down our rules. Remember, if we're adding integers together, if they have the same signs, we're going to add them and keep the sign. Different signs, we're going to subtract them, and then we take the sign of the bigger number. Who's going to win, the positive or the negative? When it comes to subtracting integers, remember our phrase, adding the opposite. We're going to change subtraction to addition and change the very next number to its opposite. Get those into your notes. And now let's review our adding and subtracting with fractions. So first is rewrite your fractions with a common denominator. And we did a little bit of that when we were doing some comparing and ordering with our fractions. Remember to treat your numerator and denominator the same. Then you're going to follow your integer rules to actually do the adding or subtracting before you come back and do your most important step, which is to simplify your answer when you're done. You've seen a lot of this before, so it should just be kind of reminding you of how to work with fractions and then adding in a little bit of working with an integer. So here we have 5/6 minus 3/4. So first thing, take care of that subtraction. So we make it adding the opposite. The negative is always going to go with our numerator, because remember the numerator is what gets added or subtracted in a problem. Now we look at our two denominators and we need to find a common denominator. Well, 6s and 4s can both be turned into 12s. So I'm going to change my denominator into something out of 12. Now, remember our second part up here, treat the numerator and denominator the same. So I ask, what did I do to 6 to get to 12? Well, I multiplied times 2, so do the same thing up top and get 10. What did I do to 4 to get to 12? Well, I multiplied times 3, so I'm going to do the same thing up here and get 9. And then I'm finally ready to go ahead and add. They have different signs. One's a positive, one's a negative. So I'm going to subtract them. 10 minus 9 is 1. And I'm going to take the sign of the higher number, which was the positive number. So I get 1/12 is my answer. Next one, 8 and 10. So it's already addition, so I can leave that alone. I need a common denominator for 8s and 10s. Now I could use 80 as my common denominator, but a better choice, because we try to keep it as small as possible, is I could use 40. Remember to keep your negative sign with your number, so I know the negative is going to go with that numerator. To get from 8 to 40, I multiply times 5, so do the same thing up top and get negative 15. To get from 10 to 40, I multiply times 4, so do the same thing up top and get 28. Here I'm adding together numbers with different signs, so I want to subtract the two of them. 28 minus 15 is 13/40. And then I'm going to take the sign of the bigger number. The positive was bigger than the negative, so it's going to stay positive. And then I always check, can I simplify 13 and 40? In this case, 13 is a prime number, so it can only be divided by 13. 13 definitely can't go into 40, so I know I'm good there. So I'm going to talk through these next 3 problems, but if you feel comfortable with them, feel free to work ahead on me and just use me to kind of double check your work when you're done. So I'm adding, so I'm okay here, and they're both negative, so I know I'm going to be adding them together and keeping my sign, but I need a common denominator. So I think about what could a 3 turn into and a 4. A good way to do it is look at your multiplication table, look at your 3 row, look at your 4 row, what number showed up in both. In this case, I know that I can turn them both into a 12. And then I know the negative is going to keep hanging out with that numerator. To get from 3 to 12, I multiply times 4, so I do the same thing up top. To get from 4 to 12, I multiply times 3, so I can do the same to my numerator. And now I'm ready to go ahead and add. Negative 4 plus negative 3 is negative 7, same signs, add and keep, and my denominator stays at 12. 7/12 can't be simplified, so I know that's my final answer. Next one, 5/8 minus a negative 3/5. So I see that subtraction, so I change it into adding the opposite. So it just becomes 5/8 plus 3/5. I need a common denominator between 5 and 8. This is similar to the one we had in the last slide. 5 and 8 can both turn into a 40. To get from 8 to 40, I multiply times 5, so I do the same thing up top and get 25. Down here, to get from 5 to 40, I multiply times 8. So I'm going to do the same thing up top and get 24. Same signs, they're both positive, so just add them together. 49 40ths. And then my last step is to simplify. Simplify means not only dividing numerator and denominator by a common factor, but also changing it into a mixed number if it happens to be improper. In this case, it's improper. So I ask how many times can 40 go into 49, and I say one whole time with 9 left over. Last one down here, bigger problem, so I'm going to have to work a little bit harder here. I need to know what can a 10, a 7, and a 5 all turn into. Well, a 7 and a 5 can make a 35, but 10 doesn't work with that. 10 and 7 could both turn into a 70, and I can do the same thing with my 5. So I'm going to use a 70 as my common denominator. But it's good just to choose a common denominator that works for everything, so you don't have to come back and do things a couple times. The negative here is going to stay with that fraction, and now I'm ready to rewrite each of my numerators. To get from 10 to 70, I multiply times 7, so I do the same thing up top and get 63. To get from 7 to 70, I multiply times 10, so I do the same thing up top and get negative 40. To get from 5 to 70, in this case I multiplied by 14, so I'm going to do the same thing up top. 3 times 14 is 42. And now I'm going to follow my order of operations as I work through my problem. So inside the parentheses, they have different signs, so I'm going to subtract them. 42 minus 40 is 2. And I'm going to take the sign of the higher number. The positive was bigger, so it's going to stay positive. I'm done with in the parentheses. It became 2 70ths. Now I add together the other piece. In this case, they have the same sign, so I'm just going to go ahead and add them together. Remember, your denominator never changes. You're just adding or subtracting your numerators. And then last step is I need to simplify. 65 and 70 can both be divided by 5. Make sure you always show that work. 65 divided by 5 is 13. 70 divided by 5 is 14. And I get an answer of 13/14. So the problems are just like they were when you were adding and subtracting regular fractions. We just have to worry about our integer rules in that very last step.